All right, so it is time to start. So here's what I would like you to do. I'm going to give you 5 or 6 minutes. The 4 problems on the first page, just combine the things that we have done in the last 2 sections as far as translations and the stretching and shrinking. So do your best. If you need to, draw your intermediate graphs. And then you can always, on the test or anything, you can always just draw an arrow to which graph is the final answer. Okay, I am good at reading through the chaos. Okay, so get to work on those. I also, while you're doing that, I'm going to put the answers to the last 3 problems from the page last time that I had said do for homework. That way you can check your answer with mine. So good luck. See you in a minute. All right, so I did these problems while you were working. So if you missed it, you can tune into the beginning of the video next time, but these are the last three problems from last time that I finished up here. I mentioned doing it for homework. It's good practice. So just real quick on this first one, the first thing I did in pencil is I graphed 1/2 square root of x. That means I took all the y values from the square root of x and I multiplied it by 1/2. So I got this little squished down version. And then I took that graph and I went left 7 because of the +7 and then down 2 because of the -2. And so that moved, and you can see my pink final answer right there. I will have this up at the front if you want to compare your answers with mine after class. That's totally fine. And if you have any questions, please, of course, ask me. That's why I'm here. The next one down here, this was example 17 from last time. First thing I did is I did negative x cubed. For that negative, remember I told you always do the multiplication first. It's order of operations. So the negative takes the x cubed graph and makes all the positive y values negative, all the negative y values positive. And so that's why I got this graph right here in the center. That's in pencil. Okay, it is the reflection of the x cubed graph. And then because of the -3, I took that whole graph right 3. So I just counted each of these points, each of the basic points on the graph, right 3 units. Last but not least, I have this last example. The first thing I did was the square root of the negative x. Again, doing the multiplication first. So when the negative is attached to the x, what you do is you make all the x values negative. So this square root graph, instead of going off to the right like our basic graph does, I've made all the x's negative, so now it goes off to the left like this. And then I took that graph because of the -6 and brought it every point down 4. So that finishes up the worksheet from last time. And if you need more detail about that, please ask me or come by, stop by the desk later. So now here's what I asked you to do. I'm going to go ahead and just do these quickly. And if you need anything, please let me know. I'm going to zoom in a little bit, see if I can get this. There we go. Look at that. Nice and large. And oh, perfect. Okay, so if you need to, remember, I'm hoping you get to the point where you don't need to do the basic graph straight away, but if you do, there's no shame in that, that's fine. So the x squared graph looks like this. I go over 1 up 1, over 2 up 4, up 9. Same thing when I go backwards. And so here, just real light in pencil, dotted even just for fun. There's my x squared graph right there in the middle. And now what I'm going to do to that graph, because of the -4, is I'm going to take the whole thing down 4 units. So I'm going to take each of these points, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and there's my graph that has been shifted down 4 units in lovely pink ink. Boom, there we go. I'm just performing these. If you have a question, if you got something different, don't be afraid to interrupt. The next one is the absolute value graph, is the basis of this. So real quick, the absolute value just makes all of the outputs are all just positive values of the x's that I input. So it's just a v. So again, here's my dotted v that I'm doing as my basis. This is my intermediate graph. And then what I'm going to do to that intermediate graph is I'm going to take the whole thing right 3 because of the x -3. And then up 2. So each point by point, or what I'm going to do, because I've done enough of these, and this is where I'm hoping you'll be, since there's no stretching or shrinking, I'm going to take the vertex right 3 and up 2. And then I'm going to remember now that the increments is every one I go over, I go 1 up. So I'm going to go 1 over, 1 up from there, over 1 up 1, and I'm going to just keep doing that because it's very relaxing. Over 1 up 1, and there I just moved my v. I've moved my v right 3 up 2. Yeah.
So in the test, if we just put like 3 points and just draw the arrows up, that's fine. We don't have to keep going up all the way.
Up all the way by like lots of points?
Yeah.
You need to do as many points as you need. Like the parabola, the x cubed, I would prefer all those points so you get the proper shape of it. For the absolute value, I get it. It's just lines. As many points as you need to be able to draw straight lines. Okay, but please do not do this. I get this on the test sometimes. I haven't mentioned this in this class yet, but now's as good a time as any. On the x squared graph, please do not do this because I will mark it wrong. Okay, don't just say, oh, the x, if I say just graph x squared, don't do this. Woo-hoo-hoo! Okay, I understand that you know that it's a parabola, but you have not shown me the proper shape of the parabola at all. Okay, you've just drawn a smiley face there. So please make sure, that's why I'm going through this every day, is so that we know the basic points and we can draw a nice sketch of the relationship between the x values and the y values. Okay, the next one is the cube root graph. So once again, I'm going to draw the basic cube root graph. I'm going to do 3 graphs here just because I don't want to skip too many steps on you. So the cube root graph goes over 1 up 1, over 8, that's here, up 2, same thing backwards, except negative. And so here dotted, here is my cube root graph. Now, before I translate that though, I told you let's always do our multiplication first. So the first thing here is I got that -3 in front of it. So I'm going to multiply all those y values by -3. So this y value is 2. When I multiply it by -3, it becomes -6. So I'm going to make my dot right down here. This y value is 1. When I multiply it by -3, it becomes -3. Remember, when we multiply, we're not translating that this becomes the new y value. Okay, so I'm not moving this point -3 units. I am going to the new y value of -3. 0 stays 0. This y value is -1. When I multiply it by -3, it becomes +3. And then finally, this is -2, and so it becomes +6, which is right here. So just, I'm going to do this dotted, nice dotted graph. Whee! So again, it's an intermediate step. I'm not assuming you can do, this is probably the toughest one that we've done. Okay, it combines a little bit of everything. We've got translations and we've got stretching. So I've done the stretching. Now I'm going to take that black graph that's been stretched and I'm going to move it left 1 and then up 2. So I'm just going to take those points that I've got and I'm going to move each of them left 1 up 2. So left 1 up 2 right here, then this point left 1 up 2, then the origin left 1 up 2, then this point down here left 1 up 2, and finally left 1 up 2. And so I get the, remember when we translate, we get the same shape. It's just been translated. Okay. All right, last one is -square root of x plus 2. So this time on my square root of x, the negative is outside, as opposed to the one of the final examples from the other worksheet where the negative was inside and we changed the sign of all the x's. Here, the negative is on the outside. So what I'm just going to do all at once, if you don't mind, is I'm going to take that square root graph and I'm going to change the y values. So 0, 0 stays, but now the square root of 1 is 1, but I make it negative. The square root of 4 is 2, but I make it negative. The square root of 9 is 3, I make it negative. And so here's my intermediate graph. This is the negative on the outside of the square root of x. And then what I'm going to do from there is I'm going to move the entire graph up 2 units right there. So here we go, up 2, up 2, up 2, up 2. When I translate, it's the same shape. Ah, perfect. Okay, so I'm going to pause the recording now because I know I got one email with questions, and if anybody else has some questions, so let's pause this and let's do. All right, now that we've done those graphs, we are going to begin to talk about the idea of absolute values of functions. So not just the absolute value function, which we've built up some familiarity with, but what happens if I have a function, whether it's given by a graph or given by an equation, what happens when I take the absolute value of it? So I'm going to, on page 2, example 1 is my example, and I've given you there, a function f of x. It's just a upside down absolute value. That doesn't matter. I'm just trying to make up a few simple graphs here for this. What we are going to graph now is we're going to take this function f of x and we are going to graph the absolute value of f of x. Okay, that is the new graph that we are going to create. You're going to remind me of two things that are going to help us be successful on this. First off, forget the absolute value bars. F of x, that notation, is referring to what values? The y values, the outputs. So what this now tells me is I'm taking the absolute value of the y values. Well, what does the absolute value always do? Absolute value takes positive numbers and makes them, oh, some of you fell into my web of deceit. We're going to try that again. Absolute value takes positive numbers and makes them positive, the same, yes. And absolute value takes negative numbers and makes them, everything's positive. Absolute value is a very happy function. Okay, so here we go. Where are the positive y values on this graph? The part that's pointing up. So remember, the y values that are already positive stay positive. So I'm going to trace those values that are already positive. Okay, so here we go. I'm tracing them in orange. Hopefully you can see this. I'm gonna make a big mess here just so that it's hopefully as clear as possible. So this part that I'm tracing in orange, that's the absolute value. It's already positive. You with me? So what gets affected when you take the absolute value of a function are the negative values. So these values down here, and you can do this however you want. I'm just going to pick some of the values and I'm going to translate them up. So like this value right here is -1. When I take the absolute value, it becomes +1. This value is -2, becomes +2. This one's -3, becomes +3. And we see that what happens is when you take the absolute value of a graph, it starts bouncing off the x-axis. It's never going to dip below the x-axis because that's where the negative values are. So on this side, it looks like this. Boom. Now do me a favor, I'm going to give you 10 seconds. See if you can determine what the left side of this graph looks like. Okay, I haven't done that yet. Okay, let's wait just a moment. It's all good. I told you before, technology is weird. I don't know why that negative doesn't work on the square root, so we're all even. Okay, so on the left side of this graph, hopefully this is what you're doing. You're looking and say, okay, here's a -1, it becomes a positive. Here's a -2, becomes a positive. Here's a -3, becomes a positive. And whee! So the orange graph that looks like a big spread out W is the graph that you get when you take the absolute value of the original function. So it just keeps bouncing along the axis. Here's what I would like you to try next. Okay, go to example 2. Example 2, I've given you a graph g of x. I would like you to do your best to graph what you think the absolute value of g of x is. Remember, if you don't get this first 100%, we are learning. Okay, so don't beat yourself up over it. My recommendation, though, is trace over the stuff that's already positive first. Okay, that tells you where it's hitting the x-axis and everything. I find that to be very helpful for me. All right, so I'm going to get started. The first thing I'm going to do is I'm going to trace over the positive stuff. Notice this first function that I gave us all to work with, it has a starting and stopping point. Okay, so over here on the left, there's this part that I'm going to kind of bold in blue like that. And then there's this part over here, this triangle. That should be, I'm going to make blue. Can you see that okay? We doing all right? So the positive stuff stays positive when you take the absolute value. And then it's the negative stuff that changes. So I've given you a point to work with, this point down here. The y value of this point is -4. So when I take the absolute value, it becomes Positive 4. So yeah, let's bump that up right here. And now all I'm going to do, and you can do other points if you see other y values, that's totally fine. Do as many as you need to. But now I'm just going to connect that to the places where it goes through the x-axis. So notice this is where it bounces, whee, and then over here, whee, like that. You should just get the mirror image of anything that was negative. It should just be reflected, and then the positive stuff stays where it was. Try this next one, h of x. Okay, it's just a stretched out cube root function. Doesn't matter if you notice that or not. I want you to please graph the absolute value of h of x. All right, so firstly, on the left side of this, no, on the right side of this, that stuff that's already positive, I'm going to go ahead and just trace over it. Stuff that's positive stays positive. Now the stuff below, again, pick out as many points as you need, do your best approximation. We're just sketching stuff here, so as long as you're pretty, this looks like -2, so I'm going to go up to +2. This looks like -4, so I'm going to go up to +4, and if you need other points in there. But it's going to look like, if you remember when you were a kid, maybe you drew birds like this. Looks like a bird. There we go. Okay, so again, it just comes down, bounces off the x-axis, and then bounces right back up. Example 4, same thing. Do the absolute value of k of x. This is a wave. You'll see waves a lot when you get into pre-calculus and the trigonometry part, if that's your math destiny. You don't need to know the equation of it. We're just going to graph the absolute value of it. So while you're finishing up, I'm just going to do my same process. I'm going to trace over the stuff that's already positive. So there's a little bit on this end over here, and then this in the middle, and then this, and just kind of pattern keeps happening. And then I'm going to go back through, and I'm just going to do my best approximation to make the negative stuff positive. So this looks like it's down about -4. So I'm going to move up to +4, -4. It looks like it's right in between those two right there. So I'm going to move it up to +4. Again, we're just doing our best sketch. Looks like it's pretty close to the x is 5 right there. And then we've got a little bit on the end. So here we go. All I'm going to do now is and it's just going to keep bouncing along like a basketball. And we got a little bit on the end there. And the red graph is my absolute value graph. Just one more, because there's another good example. Do you have a question? Of the negative stuff, yes. And then the positive stuff stays positive. So notice this red graph is not the mirror image of the original graph. I didn't take all the positive stuff and flip it down to give the mirror image. I just made all the negative stuff the mirror image. Flip back to the first page. And the last example that we're going to do is we've got right there the absolute value, we've got x squared minus 4. This is another good one to work on. So what I would like you to do is, what does the absolute value of x squared minus 4, what does that look like? All right, once again, the positive stuff I'm going to leave positive. And what's going to change is that negative stuff. So the bottom of the vertex is at -4, so it's going to be +4. These points are both at -3, so they're both going to be +3. And so again, you see that it hops up, and my graph, that purple graph, is the absolute value of the x squared minus 4. All right, so that is graphing, taking a graph and taking the absolute value of it. So now we're going to do something a little different, and or a little different from what we've been doing recently, and we're going to solve some equations. So if I leave that there, is that helpful to anybody in the back to see, or is that helpful? If not helpful, I'm just going to turn off the projector. I'll leave it up for now, and if no one's getting any benefit from it, then you can just let me know, and we'll move on. All right, so what we're going to do now is we are going to solve some absolute value equations and inequalities. So I'm going to do example 5, which is on the top of page 3. I'm going to solve this absolute value equation right here. I've got the absolute value of x is equal to 7, and I chose to start with this because I believe this is an equation we can solve without any real skill at all. Okay, so that coming from somebody who doesn't know their left from their right. So you tell me, because we've graphed a bunch of them, we hopefully know how an absolute value works. Somebody tell me, what's a value that when I plug it in for x and take the absolute value, I get 7? Okay, I heard both. Great job, everybody. First, x can be -7, because if I plug a -7 in there, I get the absolute value of that is 7. And then second, I get x can be +7. Absolute value of 7 is equal to 7. Just to refresh your memory, because I know it's been several classes since we've solved an equation, we give our answers in a set. Notation is important to me in this instance. And so what you're going to do is you're going to use a squiggly, not a parenthesis. A parenthesis means an interval. Okay, this is -7, 7, and there's my answer. Yo.
Why couldn't you write it plus or minus 7?
You could. My math lab didn't like it. I think because they said, somebody sent me one and I read the instructions and it said list your answers with a comma between them. So just make sure you're following instructions. But on the test, if you do this, that's fantastic. I love it. All right, what I would like you to do, I'm going to leave a little space because I'm going to do a problem that's related to this, but what I would like you to do is exercise 5, right next to it. It's going to take you 4 seconds to do. The absolute value of x is equal to 12. And what 2 values give me 12? Yeah, I'm not even going to write the x equals. I'm just going to write -12, 12. There's my solution set. So far, are we so good? We're doing all right. That we know just because I think we've developed a familiarity with the absolute value. What I want to do now is I want to take what we already know, which we've done, and I want to apply it to the next one. So I'm going to do example 6. In example 6, instead of having just the absolute value of x equals 7, I've got the absolute value of 2x minus 5 equals 7. Here's what I want you to know about the similarity, though. I have the absolute value of something. It doesn't matter what it is. I'm just going to cover it up. I've got the absolute value of something is equal to 7. So when I reveal what that something is, what two things can I put in place of my hand that when I take the absolute value of them are going to give me 7? Positive 7 or negative 7, right? So whatever I'm covering up with my hand, if whatever I'm covering up has the value of either 7 or negative 7, the absolute value will become 7. So here's how you do an absolute value equation. You take whatever's inside the absolute value, whatever you're covering up with my hand, and you make two new equations. First, I'm going to solve this. 2x minus 5, notice don't change the sign. We talked about that earlier. That is not a property of absolute value that I can just change the sign of each individual term. So I take the 2x minus 5, no more bars, and that has to either be negative 7. So if I was to erase the 2x minus 5 and put a negative 7 there, that's what I've just written. Or the 2x minus 5 could be 7. If I erase the 2x minus 5 in the absolute value bars and put a 7 there, then it's going to work out. And so now I have two equations that I solve, and that's going to give me my two answers that solve this absolute value equation. So the first one, I'm going to go through these. I'm not going to write our steps because I don't know that these are super complicated equations. If you have any distress, though, please let me know. I'm going to add 5 to both sides, and I get 2x equals negative 2. And I'm going to divide both sides by 2, and I get x is negative 1. There's my first answer. Always check, especially at first if you're not feeling certain. When I put negative 1 in here, what's 2 times negative 1? Negative 2. And then negative 2 minus 5 is negative 7. And the absolute value of that is, woohoo, we did it. All right, here I add the 5, and I get 2x is equal to 12. I divide by the 2, I get x is 6. And you can similarly check that. I'm not going to. And my solution set is negative 1 and 6. And there we go. What I would like you to do is the same thing for exercise 6. It's an absolute value equation related to the one that you just did. Somebody give me one of the equations that we're going to solve. I don't care which one. Perfect, that's great. Notice we didn't change it from a negative 9 to a positive. Whatever is inside the bars stays exactly as it is. And then what's the other equation going to be? Perfect. So I'm going to solve both of these. First, I add 9 to both sides, and I get 3x is negative 3. Divide both sides by 3. My first solution is negative 1, and I'm going to leave that to you to check. It is going to work perfectly. And then I add the 9 over here. I get 3x equals 21. When I divide by 3, I get x equals 7. So my solution set is negative 1 and 7. If there's a question, ask it. If not, move down to the next one, exercise 7, and I would like you to solve that and find my solutions. Give me one of the equations that I'm going to solve, please. 6 minus 2x equals 11. Great. What's the other one then? Doesn't matter what order you do them. Those are the two equations you're going to do. So first one, I'm going to subtract 6 from both sides, and I get negative 2x is going to be equal to 5. When I divide both sides by negative 2, I get x is negative 5 halves, or negative 2.5. I don't mind decimals as long as it's a terminating decimal. If it's some sort of repeating decimal, like a third or something, I prefer the fraction. Over here, I'm going to subtract 6 from both sides, and I get negative 2x is equal to negative 17. This time when I divide both sides by negative 2, I get positive 17 halves, or 8.5. My two answers then are negative 5 halves and 17 halves. Question, comment, concern about that? I've got one more straightaway equation for us, and I've got a purpose for asking it, the one right below it. Before you get started, I don't think it's not really anything more challenging, but I just want to make sure we're all doing the right thing. So I've got the absolute value of 3x plus 2, and then I've got a plus 5 equals 15. What is different about this equation versus the previous two we've done? Yeah, there's something outside the absolute value. You're going to come across homework problems that there might be something added or there might be something multiplied in front of the absolute value. Before you create your two equations, isolate the absolute value. So what I mean by isolate the absolute value is I need to take this 5 that's outside of it and I need to move it to the other side of the equation. How do I do that? Perfect. I figured you knew. So now I've got the absolute value of 3x plus 2 is equal to 10. So from there, I'm going to give you 40 seconds. Make as much progress on that as you can, finishing it up. My point to this problem was just always isolate your absolute value before solving. Check your work with my work. You might not be finished. So the first equation is 3x plus 2 is equal to negative 10. 3x plus 2 equals positive 10, or vice versa. The order, again, is unimportant. So then I subtract 2, and I get 3x is negative 12. When I divide by 3, I get x is negative 4. There's my first answer. You can always check on the test. I highly encourage checking. That way you know when you leave the test, you got it right. Subtract 2 on this one, I get 3x is 8. Divide by 3, I'm going to leave this as 8/3 because that is a repeater. And so I've got negative 4 and 8/3. Those are my two answers. We'll come back. Our last example from this section is going to be another equation, but it's no different than what we've done. But before we get to that, I would like to talk about solving an inequality that involves an absolute value. So if you notice, if you look up on the sheets that I gave you, my example 6 is the absolute value of 2x minus 5 equals 7. And so in example 7, I don't change much. It's just the absolute value of 2x minus 5. And I put less than, just strictly less than 7. And there's a method to my madness. I did the same thing for you when you go to do your exercise 9. That's related to the equation you solve, because here's the method I want to teach you. Now, there are other methods to solve inequalities. So if you've had an algebra class before and you got taught a method and you love it, then please use it. Okay, I'm not saying this is the end all be all. The reason I'm going to show you this method is because it will work for every inequality we do in this class. When we get to square root inequalities, when we get to rational inequalities, when we get to quadratic inequalities, this is going to come up again and again. And I'm going to show you the same method no matter what, so that you just have one way to do any inequality. So the first thing you're going to do, any inequality that you come upon, is you are going to solve the related equation, which we've already done. What that does is it finds boundary points for you. Now, the second thing you're going to do, it doesn't really affect, our absolute value too much. It won't affect when we do our quadratic, but it's a good habit just to make sure it's in your brain somewhere. The second thing you just want to do is, what's the domain? Well, what's the domain of any absolute value? Think about the graph, the V. How far left and right does the V go in our graph? Negative infinity to infinity. So there's no restrictions on my domain. Okay, so the domain in my absolute value is negative infinity to infinity. That'll come into play when we talk about rational inequalities and we talk about square root inequalities. The domain plays a part in the solution, but I just want you to aware. And then, so the last thing we're going to do now is we are going to do a number line test. So if you don't already have a way to solve absolute value inequalities or any of the others, this I think is going to get you the most bang for your buck because it's going to be the same process no matter what you do. So we've already in step one for this inequality, we've already done it. Who can read up on their page and remind me what's the solution set to the related equation? -1 and 6. Great. What we've done is we found the boundaries. We have found the places where there is equality here. The reason I found the domain is now I'm just going to make a number line. And since it's negative infinity to infinity, I'm going to use the whole number line. Okay? This is my domain, negative infinity to positive infinity. And on that number line, I'm going to put those two boundaries. I'm going to put -1 right here, and I'm going to put 6. So notice, when I put those numbers on there as my boundaries, how many intervals do I now have? Count with me. How many do I have? I've got 3, okay? And so if -1 and 6 are the two places where it's equal, then it stands to reason that it's either bigger or less than in the intervals. And so we're going to use the number line test. And all the number line test says is pick a value in each of the intervals and test it. Okay, that way you're just doing a little arithmetic. So in this first interval, which is negative infinity to -1, what's a number that I could test in this interval? -2, -8, -45, whatever makes you happy. I'm just going to use -2 because it was the first thing I could clearly discern. So when I put -2 in, we're going to see, is this relationship less than or is this relationship bigger than? So here we go, -2. What's 2 times -2? -4 minus, what's -4 minus 5? And what's the absolute value of -9? Is 9 less than 7 or is 9 bigger than 7? I'm going to put a bigger than. Okay, so, and you can test another value. If you don't trust me, okay, because maybe you don't, we haven't known each other that long. If you don't trust me, pick a couple more values in here and determine that it's always now, any value in this interval is going to be big. It's going to create a relationship where this side's bigger than that side. Give me a value between -1 and 6. 4. Super. So let's plug 4 in. So when I do that, what's 2 times 4? And 8 minus 5 is 3. What's the absolute value of 3? Is that less than 7 or is that bigger than 7? It's less than. Now you might say, hey, can I just alternate? And for absolute values, yeah, you can, but test it because not all functions alternate. Okay, so you could, later functions, you could get greater, less. It can happen, so it's good to just get in the habit. So I'm going to pick a value. I'm going to pick 10 just because it's on my mind. So here we go, 10. 2 times 10 is 20. 20 minus 5 is 15, and the absolute value of 15 is bigger than 7. So really what you've done is you've solved both inequalities now. Okay, so in the homework it says solve both. You've already done it. Now we can determine what's the interval where the absolute value of 2x minus 5 is less than 7. Tell me, is it interval 1, 2, or 3 that answers this question? Interval 2. What are the boundary points of interval 2? And am I going to put parentheses or brackets on the sides? Parentheses or brackets? I don't care about the equals. I don't care about these endpoints where it's equal. So I'm going to put parentheses. If this was a less than or equal to, what would I put on the ends? Brackets, great. All right, so what I would like you to do, please, is on your page, do exercise 9. Yes, question?
What did you mean by you already solved both of the intervals?
Because if I then said, okay, when is absolute value of 2x minus 5 greater than 7, where is it greater than? Here. So you've already solved both problems. Well, I only asked you one, but there's some problems, I think, in the homework where it says solve both of these. So it's not two separate problems. All right, earlier we solved the related equation. What were the solutions to the related equation? -1 and 7. Thank you. So now I'm just going to test the 3 intervals that happen on my number line. And so just check yours with what I get. We should all have the same conclusion. So I'm going to put in like -3 on this side. So 3 times -3 is -9. -9 minus 9 is -18. Absolute value of -18 is indeed bigger than 12. I'm going to put 0 in from in between here. So when I put 0 in, 3 times 0 is 0, minus 9 is -9. Absolute value of that is not bigger than 12, it's less than. And I'm going to put 10 in. 3 times 10 is 30, 30 minus 9 is 21. The absolute value of 21 is 21, which is bigger. The question I ask is, where is it bigger? Well, there's 2 intervals this time. How would you define this interval right here? And then we are going to use a union. We are joining. This is all one set. So this is unlike when we did, where is it continuous, or where is it increasing, decreasing, and constant, where you were just giving, answers. And then how would I define this interval here? So we're not going to do exercise 10 just for time's sake, but what you would do first is you'd solve the related equation, and then you would just go through the same process. It's absolutely no different than what we just did. So go through to the next page. There's some thought questions at the top. I'm just going to give you 30 seconds. If you don't get it, it's totally fine. There's really no great way to introduce this, but just think about this. Absolute value of x minus 1 equals -1. I want you to write down, propose what you think the solution set to that is. All right, now if I get you on this first one, that's just my little math fun, but I won't get you on the next 2 after this. But here's the question. Is there anything on the left side that I need to move over? Is there any multiplication? Is there any thing to add? No. So here's my question. I've got an absolute value. Absolute value always gives me what kind of answer, no matter what? Positive. So will I ever get the absolute value of something equal to a -1? No, that will never happen. So what's the solution to this? No solution, empty set. If you were going to write yourself a little note so you remember, the reason for that is because the absolute value can never be negative. So it's never going to happen. So given that, see if you can now think through exercise 12. These next three problems, 11, 12, 13, they're just, they're unique situations. And I'll give you a hint, the answer to this one is not the empty set. Okay, so what's going on in this problem? It's not an equal. If this was an equal, it indeed would be the empty set, like the previous problem. But this is a greater than. Well, again, answer me this question. On the left, absolute value of x plus 7, this is always going to be what kind of number? It's always going to be a positive number. So when is a positive number bigger than a negative 10? Always. Any positive number. Throw out a positive number. 0.1. 0.1 is bigger than negative 10. It does not matter. So this is always true because we have a positive number on the left, or 0. And we have a positive number or 0 on the left. That's always going to be greater than negative 10. So the solution set to this is negative infinity to infinity. It doesn't matter what you plug in. It's always going to be true. One more. 13. And then we each have a final problem to do. And we'll save the last section for next time. All right, so once again, for the final time, on the left, absolute value x minus 5, that's always, every time, going to be what kind of number? A positive. But this time it says, when is a positive going to be less than a negative 5? When is that going to happen? Never. A positive number is always going to be bigger than a negative. So this can never happen. So once again, we get empty set. All right, my last equation, you've got one. We've got just enough time. I've got this absolute value equation. Okay, it's not an inequality. We're not going to do inequalities that are shaped like this, just equations. Let me ask you, just reviewing what we did 12 minutes ago. Forget this equation. You don't have to write this down. You know the answer to this. Forget that this is equal to another absolute value. What if it was just absolute value of x plus 6 is equal to, let's say, 11? What would the two equations be? X plus 6 equals 11, x plus 6 equals negative 11, the positive and the negative of this. So you do the exact same thing with this problem. So here's my two equations. The first one is going to be x plus 6 equals 2x minus 3. All I've done is gotten rid of the absolute value bars on both sides. The second equation is going to be x plus 6, just like you told me a minute ago for when it was equal to 11. Is equal to, and in the second equation, we made the other side negative, right? So we're going to make the other side negative. Now, here's the only thing you've got to remember. We've got to make this whole thing negative. So it's going to be negative in parentheses, 2x minus 3. Okay, not just the negative in front of the 2x, but a negative in front of the whole thing. So just for time's sake, we'll come back and solve this. On exercise 14, write down the two equations that you're going to solve. We don't have time to go through both of them. I promised I would always let you out on time. Somebody tell me the first equation you're going to solve. Okay, just got rid of the bars. X plus 4 equals 7x plus 12. What's the second equation we're going to solve? We don't change the signs of any of the terms. Okay, so it's not going to be x minus 4. We don't make this one 2x plus 3. Okay, the sides stay exactly the same. On one, hi everybody. Glad it's Wednesday. Sorry. You were right, I was wrong. I'm not afraid to admit that. So these should both be -4s. My apologies. But my point is the same. You leave them exactly the way they are. And then the only thing you change is one side, you take the two terms exactly the way they are. On the other side, the exact negative. I just want to say, don't pack up yet. Just one more thing before we go. First off, on this side, don't forget to distribute. Common mistake on the test is forgetting to distribute. So I don't want you to do that. So that's the end of this section. So you say, hey, Mr. Perkins, you